the one we just did, the integral was negative 1 over x, but Miss Brianna says this is not 1 over x. This is 1 over x to begin with. So Miss Brianna, what's the integral of 1 over x? ln of x. And right now, we start to see this is not looking good. This is not looking promising. Because now what do? I got to do my FTC, right? I've got to take the limit as n approaches infinity of ln of n minus ln of 1. Well, ln of 1, easy cheesy, what is that? 0. But oh my Lanta, what is that going to be? Infinity. So you're telling me that that area was heading towards 1. And that one's going towards infinity.
First, can you stop?
I don't understand.
Can I drop out?
So it is very, very important for you not to rely on the graph, but to rely on your algebra. Because by looking at these two graphs, you would have thought, okay, I mean, kind of the same graph. I mean, maybe this might be 2, but let's stick with a number. And we are not sticking with a number. Algebraically, why is this happening? Because look at your integral of 1 over x squared versus your integral of 1 over x. The integral of 1 over x produces an ln, not 1 over x, negative 1 over x, like 1 over x squared did. Which unfortunately, when you start to take limits, it does matter because the x is on the bottom, which would throw it to 0, whereas this is not going to have an x on the bottom. It's going to be an ln of infinity, which is infinity. So this is divergent, or diverging, or whatever you want to call it, but it diverges. And the issue here is going to be that you're going to have to let it go. And the letting it go is going to be based solely on your algebra skills, that you're going to have to rely heavily on the algebra. Okay? All right. So let's see one where we have a double whammy. And I say a double whammy because the previous two, the integral was going from 1 to infinity, and I only had one infinity that made this improper. But now I've got 2 infinities that make this improper, and that is a big fat no-no. Yes? Oh. The answer is 0. But we'll talk about why. It is 0 because this is a symmetrical function. One is below the x-axis and the other chunk is above the x-axis at 0. So it looks like this and then it looks like that. And so this does cancel. But this is the only reason why. Okay? It does not go to 0 because it goes from negative infinity to infinity. If this was not symmetrical, the answer would not be 0. Does that make sense? So Dalton is right. The answer is going to be 0. But it's 0 because it's symmetrical to the origin, which makes it 0. Does that make sense? Mm-hmm. Okay. So let's do this algebraically, and let's figure out how we would approach something that is negative infinity to infinity, and I've got a double whammy. I said something about symmetry to the origin. So I need to do these limits that Con did on the previous one. So I'm going to write the limit as m approaches negative infinity, and I'm going to go to 0. Why can't I pick n, like going from m to n, because I can't write that many limits here. I can only write one, so I've got to split it. So it's got to be x to the it's got to be x e to the negative x squared plus, and now I can do another limit going from 0 to n of x e to the negative x squared.
Why can't you just do negative n to n?
Yes, somebody asked that in the previous class. Thank you. I was going to say equation. I was like, no, that's not what I'm looking for. Yes, somebody asked, can I do like the limit as n approaches infinity and then just do negative n to n? Unfortunately, if you have two of these guys that are just n's, you're going to automatically cancel them, which would make it automatically 0, and they're not all going to be 0. So don't automatically cancel them off. And so you would have to split it, unfortunately. Again, this one will be 0, so this one you technically could have, but you don't know that. All right. I can't integrate this like I did 1 over x, like I did 1 over x squared. What do I need to do here? U sub. You can choose to do a positive x squared or a negative x squared. I honestly think it's easier if you do a negative, because that way you just have e to the u and you don't have to worry about it. But that's up to you. All right. So as I told the other class, things just don't ever go away here, right? You've realized that since August. Things just keep popping back over and over and over again, so we can't forget how to integrate. So when I do integrate this, can we agree that this is going to be a negative 1/2 from m to 0 of e to the u du? Can we agree with that? And I'm not going to change my limits on these because, heck, I've got to change everything. So I'm going to leave them and then I'll plug and chug.
Would you not put the negative 1/2 in front of that one?
I sure do. I was about to do that and erase this because that looks hideous. There we go. Okay. E to the u. What's the integral of e to the u, guys? That one's easy. E to the u. And I'm going to go ahead and replace it so we don't forget. And that's from m to 0. And this is the limit as n approaches infinity of negative 1/2 e to the negative x squared. The good news is that you've already integrated, so you don't have to worry about doing that again. But there she is. All right. Now it's the plug and chug FTC. Here we go. This is going to become negative 1/2 e to the 0 power minus e to the negative m squared power. And this is all heading towards negative infinity. This is all heading towards infinity. And this is e to the negative n squared minus e to the 0. I have not taken a limit here, and I am showing a lot of steps here. So there are some of you that could probably skip some of these steps. I'm totally game with that. So here we go. Yes, sir?
I just want to say that left limit doesn't look like there's a negative in
It does not.
for the video.
We're going to slap it in there, though. You're absolutely right. All right. I'm going to go ahead and take my limits. So this is going to be e to the 0 minus e to the negative infinity squared. And this is going to be negative 1/2 e to the negative infinity squared minus e to the 0. All right, let me make sure we're clear about this. Are these two the exact same thing now?
No.
Right now, they're not, but they will end up becoming the same thing. So somebody in the other class asked me, negative infinity squared, is that not the same as that?
No.
And the answer is a big fat no. So be very careful. Not that it matters on this one because they're going to both be negative anyways. But this is negative 1/2. Can we all agree this is 1?
Yes.
Minus e to the, and I'm going to write it like this, see if this makes sense. Are we good with that? Yes.
Oh, no, my turn.
Okay.
Did you go ahead and distribute those?
Oh, absolutely. And I'm going to. I'm just trying to show as many steps as I can.
Wait, why is the infinity squared?
I mean, infinity
It's
squared.
right,
You're
it's
still
right,
rich.
yeah.
Yeah. You're even richer.
Some infinity would be
But you're right. It is technically infinity squared.
Yeah.
What the heck is this? That is a big number on that bottom, isn't it? It is huge. So this is really negative 1/2. Minus, this is also 0. So really plus 1/2. And as Dalton had said, it is 0. And it is only 0 because if I were to look at the graph of this thing, the graph of this thing looks something like this. Ooh, that was not symmetrical at all. Something like that. Okay? Mr. Zander.
So to check your work, could you do a test to see if it's symmetrical about the origin?
You certainly could. Absolutely. That would be a very lovely algebraic test. Of course, you could plug it into your calculator to visualize it too. But what if this was not on a calculator active question? Then you'd have to do that. The negative x has to equal, like negative x, has to equal negative of the function.
And what's the same? So is it like odd is?
That's odd.
Yeah.
Yep. Odd and origin mean the same thing.
Yeah.
Like if a function's odd, then it's symmetric to the origin. If a function's even, then it's symmetric to the y-axis.